All right, hi guys, it's Mr. C with your Saxon Math. Today we're doing lesson 92. Now this lesson covers a bunch of different things. We're going to start with expanded notation with exponents. And this is something that we did much earlier in expanded notation. And so that will be a little bit of a review. Then we're going to do order of operations. Again, we've done order of operations before, but now that we've learned more math, it's a little more complicated, and so it's a little trickier in this lesson. And then the power of fractions. Now the cool thing about this lesson, out of all the lessons we've had so far, this might be the most important lesson or the most important practice in regards to testing, both this year and in future years. There's a lot of problems that we'll do today that you will see on your standardized tests for the rest of your life, quite honestly. You're going to see this now, you're going to see it in high school, and even in college entrance exams, and even tests that you'll take in college. Some of the kinds of problems that we have today, they put on tests that you'll see for the rest of your life, because they're the kind of problems that most people forget and it trips people up. And so these are good things that if we practice them now, you're really going to see benefits from them in the long term. So let's dig into it. All right, in lesson 32, we started with expanded notation, looking at whole numbers. So with our number 365, we pull that out to the 3 to the hundreds, the 60 is to the tens, and the 5 is to the ones. So 3 times 100, 6 times 10, 5 times 1. And the way that I remember how to do this is you just take the number of zeros with however many spaces you have after that number. So after 3, there's 2 numbers, so it'd be 2 zeros. For the 6, after the 6, there's 1 number, so there would be 1 0. After the 5, there's no more numbers, so there's no 0. So that's how I remember to do it with expanded notation. Now, to use exponents, all you have to remember is how many zeros there are, and in place of the zeros, put a number. So if there were 2 zeros for the 100, it's a 2. If there was 1 0, it's a 1. If there are no zeros, then it's a 0. So that's a really easy way to remember it. Now, we have a chart here, and you have a chart in your book, but you're not going to remember all this. Just remember that to count the number of zeros or the number of placements. You're not going to remember that the 10 billions place is a 10. Well, you might. I'm not going to. So it's easier just to remember how many zeros you have. All right. So let's look at this first one. The speed of light is about 186,000 miles per hour, right? 186,000 in expanded notation. So again, we're going to take our numbers, our 1, our 8, and our 6, and we're going to look at how many placeholders we have after them. So after the 1, we've got 1, 2, 3, 4, 5. So we could do 1 times 10 to the 5th plus 8, and then it's 10 to the 4th, plus 6 is 10 to the 3rd. So you're just, again, counting those zeros, counting those placeholders. So we've got 1 times 10 to the 5th, 8 times 10 to the 4th, and 6 times 10 to the 3rd. All right. Now we're just going to review order of operations. You simplify within parentheses, then powers and roots, multiply and divide, and then add and subtract. We have, I always just remember PEMDAS, but a lot of students like to remember, please excuse my dear Aunt Sally. And the P, of course, is for parentheses. E is for exponents. Roots is part of that, but we just remember roots and exponents start together. Then multiplication, division, addition, subtraction. So let's try one of these. Again, this is the kind of problem. I had these kinds of problems when I was in graduate school. So when I took a test to get into graduate school to get my master's degree and then my PhD, I had problems like this in the test because they want to see if you remember the order of operations. So we want to do parentheses first, right? Actually, I'm just going to go through this a step at a time because it has it on the slide. So with the first one, we simplify the parentheses. 8 plus 8 is 16. So that's the only thing we've changed. Now we go to the next thing, PEMDAS. E is exponents and roots. So now we're going to be looking at the 16 and the 3 squared. So we change the 16 to 4. The 3 squared is to 9. All right, so now we just have 5 minus, and I rewrite it every time. Even when I do this today, I write the steps just like this, because if you don't, it's easy to just start going left to right. All right, 5 minus 16 is negative 9 divided by 4. Don't do that. Right? Do it one step at a time in the order of operations. So now we've done the PE, so it's multiplication and division now. So now we can do 16 divided by 4, not 5 minus 6 first. You do 16 divided by 4 and 9 times 2. All right, so 6 divided by 4 is 4, 9 times 2 is 18. Now we can do addition and subtraction. And multiplication and division go the same, they're the same weight. You start left to right. Addition and subtraction, same weight, go left to right. So now we can just go 5 minus 4 is 1 plus 18 equals 19. Now, if we don't use our order of operations, we're going to get completely different answers here. And so it's important that you go in the right order. Okay? Finally, so now the third part of today's lesson, we're looking at exponents. And we have never done this before. We're using exponents with fractions and decimals. That means that, like in 1/2 times 1/2, when you have an exponent, that's just times the same number, right? It's not times 3, it's times this whatever's in that parentheses. So in this case, it's 1/2 times 1/2 times 1/2. And we can do that. 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. So we get 1/8 is the same as 1/2 to the third power, or cubed, or to 3, or whatever. 0.1 squared is the same as saying 0.1 times 0.1. If it was 0.1 to the fourth, it would be 0.1 times 0.1 times 0.1 times 0.1. And that's it. It's not real complicated. So if we take this example here, it's 2 to the third with an exponent, so it's whatever is in that parentheses. So in this case, it'd just be 2 to the third times 2 to the third, 2/3, or 2 over 3. So then we just multiply numerator times numerator and get 4, denominator times denominator and get 9. This can't reduce because there's no common factor, so our answer is 4/9. And that's it. So not a lot of new stuff here, it's just practice doing hard stuff. So if you want to go through some of the practice set here, that would be great. Let me throw up the answers real quick. And good luck.